for the delay. My dinner went a bit longer than I expected, so I'm late by half an hour. A bit more than half an hour, actually. More like 40 minutes. Ooh, boy. Okay, let's get some music going here. That's
Was it a
good.
good dinner?
It was a good dinner, though, yes. The dinner was about some European Lisp Symposium 2020 discussions. So if you're interested in Lisp and you would like to meet more people also interested in Lisp, the European Lisp Symposium is the way to go. It happens once a year, usually in spring around April. Next year it's going to be, so in 2020 it's going to be April 28th, 29th in Zurich.
Your dinner went into overtime.
It did, yes. So I was talking to a co-organizer about some things, and then we just talked other crap as well, and it went overboard. And now I can't type. Amazing. Alright, let's load up our cl-markless system. So last time, yesterday, we spent some time going through a possible syntax format for dialogue things. Yes. So we discussed the kinds of features a dialogue system is going to need, and we also talked about what that would look like in terms of a compact kind of markup language, which is based off of markless. Markless being a ASCII-based text markup system. So, today we're going to start implementing the first step of putting this specification into practice, which is to add all the necessary syntax extensions. So we're going to be looking at how in cl-markless you add new directives and you parse new kinds of text. Okay, so as a first thing though, let me pull up some things. cl-markless, readme, and where's the components, I believe. Is there a printer, a recursive thing? I think there was a representation for it that was useful. Printer, output, what was it? Debug, right, that was the one I wanted. Okay. Right. So let's first have some examples to see at how cl-markless actually works. Hello Finn, good evening to you too. You did not miss much. Okay, so cl-markless is a parser primarily. It's more of a framework for it, but so let's parse some things. We're gonna do a basic kind of text. Let's see. We're gonna say this is a header, and this is some body text. We are simply doing one singular paragraph here, but with multiple lines. So like this, and then we can do a separate paragraph. This is another paragraph. Whoa! Let's make that big. There we go. Was it large? I forget. Maybe it was large. And then Chimera said, "Good evening, everyone." Okay, so now it parsed this text, this string, into an AST, an abstract syntax tree, which represents this in a more structured form. This is all the parser does, which might not sound like much, but it is enough. So let's look at that. We can use output of the component format debug. So this is the structured representation of this. So we have a root component which is equivalent to the entire document, so that everything is a part of the root component. Then we have a header with some text, and then we have a paragraph with 2 lines in it. And then we have another paragraph which has text "this is," and then has italic text another, more text, and then it has a compound markup with a size option of 2em, which means the font is doubled in size. And then we have a block quote header, a block quote, and within that another paragraph. So you can also do that with, for instance, if we have multiple things in this. So, you know, if we do that instead, whoops, let me short that down. Right, so even though things are nested, it still recognizes paragraphs and whatever correctly and nests them as necessary. So this gives you, the parsing gives you a tree, an abstract syntax tree of all the text as actual, like, semantically relevant components. So the first job is making this parser recognize more things and translate more things into different kinds of components here. So if you look at our spec, that's not the spec. This is the spec. What do we have? This is a pretty simple one. The jump directive is a singular line directive, meaning that it takes up a full line of text, and all it does is it looks for a angled open bracket and a space, and the rest is a label. So that's it. Defining that should be pretty easy. So let's go into our scratch buffer here. Put it down into common list mode, and we're gonna just go ahead and have a look at how cl-markless actually defines its directives. So in directive.list, we have the implementation of all the different kinds of standard directives. These are implemented as classes with certain methods being implemented. You can, so if you paid attention to this, I might be going a bit fast, but in the parse we have a T here at the end, which corresponds to a parser instance. And this means we can construct our own parser instance, which has different kinds of properties. So you can disable certain directives so that they aren't parsed. So it's, for instance, if you're, say, working in a restricted environment, like a website or something where you have a comment section, certain directives might be harmful for what you want to allow, so you can disable those so they're no longer parsed. You can also add new directives to this, and you can change how line breaks are treated, and other things like that. So, for instance, if you, one of my websites, which is an image board, has certain extensions for linking to different boards. So I implemented those as new directives, which are then added to this directives list when things are parsed. That way, you can sort of provide syntax extensions as part of a library, rather than having to, you know, affect everything and possibly causing things in other places to be parsed odd or not as expected. So what we're going to do is we're going to add new directive classes that encompass this parse behavior, and when we actually parse our dialog stuff, we're going to use these directives in addition to the other ones that exist. Okay, so let's have a look at how some of these are implemented. What would be a good one? The block quote header is very similar to what we want. So what does it do? It defines a class block quote header, which is a singular line directive, and then it defines two methods called prefix and begin. Prefix is a method that returns an array of, well, strings in this case, but they're essentially characters. Well, there's sets of characters that can occur. So in our case, we're gonna have a angled open bracket and a space. So we can start plugging this in. let's say def class, what was it called? Jump, I believe. Jump, yeah, jump. And this is gonna be a cl-markless singular line directive. Okay, and we're gonna add our method prefix jump, and this is gonna be a constant of this and a space. The reason there's strings again instead of just singular characters is because you can have multiple characters for the same position, sort of. So this is position 0, position 1, so you can have different choices there if your, I guess if your directive has aliases or other kinds of things. Let's actually see, where is that used? For instance, yeah. So for instance, an ordered list is represented as this, where you have any kind of number followed by either any kind of number or a dot as a sort of a necessary prefix. Or for the header, you can have either you have a pound or then another pound or a space, and this is so that you can have you know, headers that are either this, which is a top level header, or you can have this, which is a second level header, or you know, beyond that. Now for line directives, the convention in markless is that the first two characters should be indicative of which directive you're going to have, which is why there's never more than 2 characters in this. These prefixes are used to compile a dispatch table, which efficiently dispatches to the necessary directive based on a parse tree. So it does an efficient way of determining which directive is used. Okay, so we have our prefix function, and we need our begin function. The begin function is a bit more important because it does some actually interesting stuff. So again, looking at our block quote header, which is going to be very much the same thing. Actually, let's see. The way the parser works is that after it notices that a prefix has been matched, it calls begin, which allows the directive to start consuming additional prefix things. So if your line has additional kinds of metadata, for instance, in an ordered list, it would have, you know, this number which can go beyond 2. The idea is that it consumes this prefix. And after that, control is sort of returned to the main parser loop, where it can try to match again for an additional kind of an additional block or line directive. So you could have things nested, right? So that's why you return control after begin. After begin, if you have multiple lines or something like that, you can then invoke is called repeatedly, which allows you to gather more information as the parsing goes on. So the parse state is kind of complicated, but for now we don't really need to get into that at all. We'll get to that once we do the conditional. For now, because our directive consumes the entire line, all we need to care about is the begin function. We're just going to fetch the entire line, read it out, and do what we need with it. So let's go back to our block quote header. So in the begin function, it does this, which is a bit verbose. So let's look at it. First, the parser has a stack of currently active directives. This is in order to keep track of what's currently being parsed, and especially if you need to traverse the stack, then this is going to be relevant. So, for instance, if you have something like this, fuck. Hello, LC Pablo. So, if you have something like this as an example, then it's going to start parsing the block quote, and then it notices another one, and then it notices a text, then notices a bold, and so forth. And for each of those, it adds a new entry to the stack. Once an entry notices that it's ended, then it pops itself off the stack and causes an unbinding. This happens for a single line. So the stack is built up as this line is parsed, and then once the line is over, the stack is not unwound. Instead, what it tries to do is first it tries to rematch. It tries to traverse the stack upwards and rematch all the directives that matched previously. So in this case, it's going to match a block quote and another one, and the third one is going to fail. At which point, it's going to unwind the stack to this point and then continue parsing from there. So this way, we can represent directives that span multiple lines without having to have some kind of complicated logic of knowing where we are or how the directive is going to match things. So that's very important and kind of how it works. So what we do here, the stack is a coupling between which directive is matched and also which component is being output. So the actual result in the document is associated with the directive. So what we do here is we fetch the current component, sort of, which sits on top of the stack, and we access the children array so that we get the array where all the children component of that top component sit. And then we do this, which is badly indented, which checks if we have a predecessor, and then it creates a block quote header component, which is what we actually want to output. And then it does something which is unique to the block quote header, namely that the block quote header can either come before a block quote, so we can have foo and bar, or it can be bar and foo. These two are equivalent in the eyes of Markless, which is why it does this predecessor scanning in order to see whether the previous component was a block quote, and if so, associate itself with that block quote. We don't need to do that for our jump tag. We can ignore that part. Then we commit our directive and the component to the parser stack, and we advance the cursor 2 steps forward. Okay, so we can just copy pasta this and remove what we don't need, which is we don't need the predecessor and we don't need this check, we just need this. Whoa. Okay, right, I don't have a file for this, that's fine. Okay. Right, we also don't have a local nickname, which I should use. Wasn't there an easier way of retrieving the top stack? I believe there was. Let me check real quick. Parser, validate instruction, no. Copy line, commit process stack, block, read URL, read inline, no. Really? Such a frequent operation, I was sure I had something. Stack top, stack bottom. No, seems not. Oh. Well, alright. Seems I have no shortcut for that. Right, we also need to define an additional component. So actually, let's create a new class here. I know I'm not doing this in Leaf, and that has a good reason, but we'll get to that later. What do we call this? Dialog. Use cl, and we local nicknames, components, cl. I think it's org. Probably that. While we're at it, let's also alias markless. let me just make sure that what things are correct. Or markless components. Yes. Okay. Actually, we don't need to have things in the components thing. We do need it for that, though. Okay. File that in package, download. Okay, actually, this is bad. It should be. There we go. Nice and long package names. Compile that in. Okay. Yes. Should also remove this. What is this? Oh, it's never used, so we never even use this. Okay, cool. Which means we can reduce this to this. Okay. Fantastic. Now, we actually don't really want to put a block code header. We're going to define our own component as well. Jump. I guess jump block or something. Or, yeah, sure, whatever. Let me see which components we need. This is not going to be a parent component. It is a block component, though. Yes. Where's the label? There's stuff that has labels already. Let me see if I have a class for that. The target. Yeah, so we have a target, but there's no specific class for it. Okay. Let's do that then. What was it? Was it not block component? Come on, it was that, right? Yeah, it was block component. I guess Slime isn't smart enough to get that. Yeah, okay. And we need the target, which is going to be that. Let's just...
You're doing a good job.
Thank you. How are you doing, Minty? Jesus, bird, stop being mad. Okay, so our begin method is actually not over yet, because we need to consume the rest of the line and put that into our target. And we can do that by simply using a subsec of line plus 2 of the cursor. And then we output the length of the line as the new cursor. This will immediately end things and cause the directive to be popped from the stack again. Okay, so that should be all. Now we can test it. Okay. Right. Actually, yeah, okay. Let's see. Foo. And now we need to make
I have a pinched nerve in my left shoulder, so I've been feeling periodic stabbing pains down my arm, mild numbness, and some twitching.
Sounds great. And jump. There we go. Okay, so it parsed it. Let's see if it actually worked. Yes. Hooray! There we go. Now we have a new syntax added to the markless language that actually parses into the correct
First try.
thing. Yep, first try, baby. Let's actually put this in a thing here. Let's make this a bit easier. So this way we can easily add more directives without having to, repeat all this crap. Okay, so that's the basic step of adding a new directive. Now this was obviously a very, very easy one to add, but nevertheless, pretty good. Okay. One thing to note is that this will immediately work even if you do like escape new lines. So if you escape a new line, it'll still work just fine, or not. Maybe it didn't parse correctly, that's weird. Bad. I'm not actually sure what's happening there. Huh. Well, never mind. I've eaten my shorts and words and also everything else. Good. Let's just move on and tackle the next easiest kind of thing. Next easiest I would expect to be the placeholder directive, which is an inline directive that just scans for a form and then calls the closing thing. Okay, that's easy enough. Let's see. So this is now not a block directive, but rather a inline directive. So let's have a look at a couple of those before we start. What would be similar? I guess like underline. So underline is the surrounding inline directive, which ours is going to be as well. Again, it has a prefix defined, and it has a begin function, which is now very similar to ours because it doesn't need to do anything else. Just starts a new component, advances the cursor, and it has an end function which detects when the actually, that's interesting. So this end function is not quite what it seems. So the way these surrounding inline directives are done is that it automatically sort of recognizes when the prefix the directive ends based on the prefix. So if it notices the same prefix again, it assumes this is the end of the directive because most of these directives are balanced. And so it automatically ends. The end method here is invoked if your holy shit, he's mad. The end method here is invoked if your parse is aborted for some reason. So for instance, if it notices that the encompassing block ends before that inline directive actually completes. So for instance, if you have a block quote like this.
Yeah, but what about Hillary's emails?
So for instance, if you have block quote like this and you start typing bold, technically you're allowed to continue this onto the next line.
It's hell in the cell.
So you can still do bold and then there. But for instance, if your block quote then ends, then obviously this inner boldness must also end, in which case the earlier parse was invalid because there was no matching close. In which
Birds
case,
are trying out for WrestleMania.
in which case the end function is called, which allows you to sort of undo the parsing, the consuming of the prefix. So this allows you to undo a parse without having to reparse everything, which is a lot more efficient than retrying, and or rewinding and retrying. So in our case, we're going to have what was this called again? Keep naming placeholder. Also, let me rename this. We'll call this jump, and call this a jump. I don't know. This is why I added things in different packages before, so that I wouldn't have clashes. So actually, let's do that too. Let's make another package. Dev package. Rough leaf dialog components. It doesn't use anything. And then we're gonna not do that. Or let's call them cl-markless components. It's still long, but and component. Yeah. I swear I can type sometimes. I swears on my mum. Okay, good. Fuck. Okay. Jump and place holder. Okay, there we go. Good. Now we can do components jump. Let's actually factor that out into a variable. There we go. Good. We're good. Okay. Okay. Now I can do the placeholder directive, which is a markless. Well, what does the surrounding inline directive even do as a begin? Interesting clutch. Isn't really. Stack entry directive. So for current thing. Oh, I see. Okay, yeah, we don't need that. So it's just gonna be an inline directive. And we need a component, def class, components, place holder. I believe it was called. Yes. Okay, and we're gonna need a source form, so we're gonna call this form. There we go. Okay. I should call this. So in this case, the prefix is only a single character, which is this opening brace. And then when we do the begin of the placeholder, other line cursor. Also, let me read up on chat. My birds need to chill. Yes, they do. But that's budgies for you. They have no chill. Well, sometimes they have extreme chill. And sometimes they have extreme rage. Got a salad. A soap that smells like marshmallows. Gross. I bought a new shampoo recently which smells like tropical fruits, which I like quite a lot. Nice and fruity.
Vegeta versus Goku, except it's your birds.
Okay, anyway, caught up with chat, nothing too interesting. Sorry. But, not interesting, but rather not...
Well, excuse me.
But not relevant to the code. I mean... I do care a lot about you guys, but yeah.
God versus the devil is going on in the background.
Okay. Alright, let's do this, though. So, in the begin, we need to parse the source form that follows. Now, for this, I'm not actually sure. This is the closing brace, a constituent character. I don't actually know. So if you have... Yeah, it is. Okay, that's not good. So we're gonna need a new retable for this. One which has the closing brace as a constituent character. Or, what is it called? I forget the terminology. Let me read it up real quick. So I'm not spouting bullshit. Character seeding tags, original tokens. Symbols as tokens. No, I don't think that's it. Where is it? Oh my god, my browser froze. Great, thanks browsers. I remember, like, 5-6 years ago? No, a bit more than 6 years ago maybe. Browsers basically never fucking froze or crashed. Or whatever, they just did their fucking job, and now I can't go a single motherfucking day without things freezing or crashing outright, or hogging 100% CPU or some other kind of garbage, even when it's just the simplest of websites, like plain text with some images. What the fuck? Okay. Right, so it was a constituent or a terminating character, right. So we want to make the closing brace a terminating character. Good. Okay. How are we going to do that? Well... Named tables would be nice, but let's just make a standard thing. Therefore, placeholder retable, which is going to be copy retable. Define symbol macro. No, not symbol macro. Fine. What was it? What was it? For set, I think it was set macro character. Yeah, there we go. Set macro character. And it is terminating. I hate that it's inverted there. Non-terminating means T is nil is terminating. Okay, right. Placeholder read table. And this is simply going to error because it will be an error. What was this? I forget the arguments. I think it's stream and argument as argument or something. Stream and character, I believe. Set macro character. Choose a function. 2 arguments, which are stream and the char that was read. Okay. What was the error class that should happen? I forget. Beater error. Yeah. Okay. Error. I guess I should make a subclass for that, or whatever. Right. Okay. So now we have a read table that correctly flows with our things, so we can start by reading out the form. Read from string, line, EFT, F values, nil, start is at the 1 plus the cursor, and yeah, so I think actually this returns 2 values that we need. The updated cursor position. So let me double check. Oh my god, I should not have turned on the lights. This is what I've been avoiding all the other days. The birds just going nuts in the background. Yes, the object and the position. First character was not excellent. Okay, so we have to update the cursor position, and then we yep. What was it?
Tell them to chill.
Well, it won't be of any use, honestly. Yeah, so we use that. So instead of using commit, the commit function commits both a directive and a component to the thing.
They will shut up.
They do have food. They just want it. They're birds. They just want to scream. That's what they do. Screaming is their life. They do 3 things. They eat, they poop, and they scream. That's all they do. And I guess sometimes they fuck, but screaming is like 20% of their day. And if you're not up for screaming, then yeah, birds are not for you. Okay, anyway. Placeholder. This one. There we go. Right. So we get the stuff. Let me split this up better. There we go. So we directly access the children array and push that on there. And that's all we do. One thing left to do is to consume white space if there is any, and skip that and check that we have a closing parent. For whatever reason you might have white space, I don't know. So let me actually, let's not allow that. So which condition do I need to signal? I forget. That value, parts of condition, parts of error. Guess parts of error. It's kind of general though. I don't know, I guess. Would have to define an extra thing. Cursor. Okay, wait. Unless star equals, whoa. Wrong char. There we go. No, actually that was the right one. I'm a dumbass. There we go. Okay, let's test that out as well. Before I do that, I need to add it to a list. Place clipper. Okay. Parse, and we're gonna do foo baz. Where's our error was signaled? No bueno, huh? So what was this then? B. What? Oh right, we also forgot to rebind the retable and the package, but that's not really important right now. Place a folder table. And we should start, oh right, wait, we start at 1 plus cursor, so what's the problem? Oh, right, that doesn't work. Oh, now it worked. What? Okay, I guess I had something stale, I don't know. Okay, let's output that again. Right. Okay, nice. So we have the food, the placeholder, and the baz. So everything seems to be working just dandy. Alright, that's another one down. What else do we have? We have a bunch of instructions, which are going to be relatively easy to add. what else do we have? We have the emote directive, which is easy to add, or should be in the very least, so let's do that next. Components, emote. Markless components. Inline. Should have done that instead. Ah! Let's also just do it like this. Ah! Stop! Right, yeah. Placeholder. Emote. There we go. Let's also define the emote directive. Cl-markless. Which is opening and a colon. And then we again need to do everything in begin. This time it's going to be a lot easier, or it should be in the very least. So we don't actually need any retable stuff. Don't really need this. Or actually, we can reuse some of the things from here to make it even easier. I believe we should be able to do that. Yes, so yeah. Yeah, let's just do that instead. It's an inline, yeah. Okay, let's just change this to free emote. Invoke, read inline, yeah. And that should just work dandy. Really? Alright then. There we go, that should be good. So now instead of having an emote thing, it's actually going to be the content thing, I believe. Let me just check what it has here. Line component, parent component, yeah. So it just says that. I don't like that though. I don't know. No, let's not do it like this. Whoa, ho, ho. Let's not do it like this after all. They're birds. They're gonna chirp. I can turn on off the lights if it really bothers you guys that much. I can do that. I'm used to it by now, or mostly in any case. I can show you the cam if you're on there. Oh, yeah. They're both there, sitting apart. Whoa, birds.
What good boys.
They were sleeping when I came home late because it was already dark out. And once they wake up, they really, really like to just get into it and make a racket. So that's why they cannot talk. No, unfortunately, they're not tamed. I've tried, but it takes so long, so long. And especially when there's 2 or more of them, they mostly care about each other rather than about you, so... yeah. Anyway...
It's party time.
Right, so... let's just, what the fuck? That's... oh, okay. Just loop for I from cursor. Below length line. Do when EQL or aref char line I return I. If there's no end, then we error, and if there is an end, then we create an emote with the emote being the subsequence of the line from cursor to end, and then we return 1 plus end. Okay, so let's actually add that. Fucking god damn it! Why? Fine, let's not do that then. Okay. Ooh. And it didn't parse because I didn't add it yet. No. Oh, right. Whoops. There we go. Now parsed correctly. Good. Let's actually check that it always parses correctly. Yep, good. Seems good. That's another one down. We got the emote, some instructions. We do have the placeholder. Don't have the predicate or the conditional block. And those 2 are the only ones left, after and the instructions as well. Okay, so which do I want to tackle first? I think conditional part is a bit easier, so let's go with that. Components. What do I want to call this? Because conditional part is kind of a bad name. Any ideas? As a reminder, this is the thing that allows you to insert different kinds of text in the middle of something depending on the predicate. I moved my chair. Immediately quiet. Yeah. What's up? Why suddenly quiet, huh? Come on, boys. Suddenly scary, huh? They're just staring at me. Right, any ideas for a better name for the conditional part, I guess? I don't know. Expression, maybe? Nah, that's too overloaded of a term. I just fucking call it conditional part. Why not? So this is another inline component. And this one has multiple content bindings, which is kind of weird. So it's not strictly a parent component. Well, kind of is, but not really. Yeah.
You interrupted the bird discussion.
That's fine. Right. So we need to add that. Or not, let's not call it children, we'll call this, choices? Or, yeah, it's, what is your problem? Fuck.
Sorry, too tired to think about things.
Rude. Okay. So here the prefix is just going to be the open bracket. No, not emote. So this is actually going to be slightly interesting, because I'm not quite sure how to handle this case. I'll tell you why in a second after I've figured out what to do. Read it in line right. So that's that. How did that B get in there? Actually... Or not test, predicate. No, it's not necessarily a predicate, though. Oh, I should call it predicate anyway. Yeah, whatever. There we go. So now, similar to this, we actually need to read a form. So multiple value bind form cursor of reads from string line t nil start cursor, and then we do that and predicate. Or should we just call it form instead, since we already have form? Yeah, let's just call it form instead. That's better. What? Oh. I am good at type. IR typist. So, and we're gonna return the new cursor. There we go. This is terrible, but it'll have to do. There we go. So this is not quite right yet. Mostly because read inline will stop at a bar Or what does it actually do? And char, yeah, it does a whole bunch of garbage. Not quite sure. It's not made to dispatch on two different things. So let me actually just test. Whoa. Scratch. Was this conditional? So we have T, for instance, and then we have A, and then B, like that. Whoops. Conditional part. Yeah. So I think I see an interesting way of doing that. That is interesting. I think I know how to do it. It's very hacky, but I think I know a way. Yes. Okay. Again, I'm thinking about things, so I want to be quiet for a second and actually get this going. And then, you know, do I have a... I'll walk you through it once I know it's working. How often do I mistype things? Holy shit. Don't think the...
How come if a birds are quiet?
Well, they're not. For one, okay, there's no link. Sometimes they just get tired, you know? Okay, I'm gonna forfeit this. Now. Interesting. So it fails to match, but why? So what does read inline actually do? When it encounters the end char. So it tries to consume end. And if that works, then it commits the buffer, it pops the stack, and it returns next, which is the next cursor, I believe. The next cursor position. Okay. So the idea I had is to do this. Right? Oh. Right. What else does it take? Oh. Huh. I fucked up. Okay, let me just first... Okay, good, good. Alright, so... Typically the way things work, or the way it's geared, is that a directive that can contain other directives is called a... well... it calls... Okay, wrong, sorry. Let me start again. So, when a directive can contain plain text, so actual text, and other inline directives, so things that can be mixed within the text, all it does is call read inline. And it does so by calling it with a potential end character. So when this character is encountered in the stream, it aborts parsing read inline. And it does so that you can, you know, most of the directives that either don't care about this at all, so they don't use it, or they use some kind of dispatching character and then decide whether to actually end in consume end. So for instance, if you had 2 ending characters or more, you would put the first one in here and then decide whether to really end in this method here. And in this case, though, the problem is that we don't really have either one ending character or another, because we have multiple clauses that are sort of separated by these bars. So we have multiple kinds of, you know, content binding. So we can have, look, you know, some test, predicate, and we have some bold text, and then we can have the alternative, which is like some italic text, you know. So we have 2 different things, and we can even have more of those. So read inline should both end when it encounters a bar and also when it encounters a close bracket, which you can't really do. So my idea for this right now is to manipulate it so that the bar is actually an inline directive while it's parsing a conditional part. And at that point, when it encounters a bar, it's going to start enter a new array for children, and that'll automatically sort of pretend as if we skip to the next part. So I think that should work out. So in this, we're going to just match for the actual ending character and otherwise continue as usual. So that's my current idea. So for that, we're going to need another directive, def class conditional part separator, and that's going to be a entity inline directive, I believe. Is that? No, it's not. Do I not have a thing for that? No. Oh, it's just called an inline directive. Okay, never mind. So it's an inline directive and that method prefix. And the prefix is simply a bar. So all we're going to do here is access the stack top again. Entry. If I could type at all, that would be nice. And then we're gonna simply... Wait, actually, let me... Whoops. Let's type P. What was it called? Parser error. Also, I forgot. Should be this. Okay, so that's a sanity check to make sure we're only matching this within a conditional part. And then we start a new child array, so we do that with this. And then we advance the cursor by 1, and that's all. Now, the more tricky thing is going to be modifying the parser state, because we can't really do that. Actually, if it's not that, then we should just ignore it instead. So if or can't. Can begin reject? I think it can if it returns nil. So actually, instead of erroring, it should just do that only if it's thing, and otherwise it's going to be treated as a normal character. Good. That should be good. Okay. Let's have a look-see. Okay, that doesn't really tell us much, so let's define an output on our conditional part so that we can actually see what's happening. So we use... where is it? Find output. Oh no, wait, that's not actually how we do that at all. Aid. Okay. How's the other debug stuff handled? Yeah, output children is a thing that happens. Okay. So we're gonna do this. And then we're gonna do... choices. Let's see. That's child S F. And then after that, I guess you do that, maybe. What? It's not exported. That should be exported. Or, nah, actually, maybe not. Okay. Parse it. There we go. How are new lines handling this? Let's see. Maybe this will look better. Yeah, that's a bit better. Yeah, okay. Alright, works correctly. Works fantastically. So now I actually also want to see whether the bar still works fine otherwise. A, B. No. Does not. Huh. Bade. But there is a... Why does that not work right? Directive. There is a way to abort a begin. Okay. We do the thing and then we return a new cursor. Yeah, apparently that's the way you do that. Okay, let me fix that up real quick. Where was that? Yeah, here. And this should probably be the same, so this doesn't need to be a con, it can be an if. Okay. Whoops. Okay, yeah, this is fine. Is there space there? Yeah, okay. So this might look a bit weird, because it's split up over multiple lines. A markless implementation is allowed to split up strings into multiple, well, string entities, I guess. As long as it does not actually insert additional new lines and stuff. Good night, Finn. Thanks for stopping by. I'm going to go for a bit longer because I want to finish this, and I think I can. And also, I started late, so seems only fair. Okay. Yeah. Alright, good luck trying to get up early. Okay, nice. Good. So now also, if I abort this match, oops, and don't do it, this should still work fine. Yes, good. But if I abort it, then... Okay, right, that's not quite right. Yeah. Fix me. I'll deal with that another day. Okay, final one is the conditional blocks. Now, the conditional blocks is a weirder one because it's split up over multiple different kinds of parts. Or actually, no, it's fine. It's fine. Because it actually makes use of the block quote body the same way. Yeah, this is fine. This is not going to be difficult at all. Okay, same procedure as lost things. Let's define a new one. Components. Conditional block. Conditional block. Yeah, let's just call it that. Or let's just call it conditional header. Yeah. This is gonna be a markless singular line directive. And it's gonna be very similar to the one we had for the jump. Except instead of a jump tag targets, we're gonna have a form. So let's do that, and let's actually move this upwards so it becomes before the inline directives. Inline, 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 inline. Inline. There we go. Whoops. Conditional header. Conditional branch. Slot name in an arg is a keyword. What? Oh. Whoops. I blanked out there for a second. Okay. Conditional header is a... This is entirely wrong. What am I doing? There we go, that's more like it. Okay. Again, find a prefix. Just gonna have the question mark and the space. Again. Yeah. Now we need to parse the form. Let's just do that. this. Actually, no. Yeah. Read it from the string. Line, T, now. Start cursor. Plus 2 cursor actually. And then when smaller cursor line, so if we're not at the end, we're gonna say there's an error, which is kind of, you know, not that important, but good enough anyway, and that should be it. And the conditional block branch should be much the same. So let's just copy pasta this, and instead of header, we're gonna call it a branch. And the branch does not actually need something, it can be unbound. And this is going to be the bar and the question mark. Here we're gonna try so if plus smaller plus 2 cursor. Then we have something, and otherwise we simply commit it without a form. There we go. Okay, that should be it. That should be everything we need. Alrighty. Let's check it. So let's actually just put in that sample we had. Like this. And I forgot to add directives. Okay, so we have the conditional header here, we have the conditional branch there. Good. Excellent. Excellent. It's not so nice because they're not actually tied together in the syntax tree, as you can see. They're actually just sequential in there. So once we actually get to writing a compiler, yes, we're going to write a compiler next, we'll have to deal with that. This unstructuredness of the things. Because yes, even though this looks very much like, you know, text markup, it is actually a programming language. Just a very, very domain specific one, but it is a Turing-complete programming language, and we're going to be writing a compiler for that next, which is going to transform this kind of AST into some kind of common Lisp function that can be executed in order to, you know, get that dialogue going.
Great.
Yep. Anyway, that's it. This is all the code that's needed in order to parse our additional syntax. The instructions are pretty simple to do. Let me maybe show you one example. Where is that? Is that in parser, I believe? I don't quite remember. Parse. No, evaluate instruction. Yes, here it is. think. How does this instruction stuff work? I forget. Directive instruction. Parse instruction, right. So we have a method called parse instruction with a prototype. And yeah. So let's see the example. Let's see what's a good one. I guess go. Let's go for that. Wrong place. Scratch. Go. Go instruction. Markless. Instruction. Is label a thing? No, it's not. What's the label instruction then? Message instruction, directives instruction. Is there no thing for that? I guess it just uses directives instruction. Weird. I don't even know. Is that in? I'm really confused right now. Okay, anyway, let's just use the target from there. And instruction proto. Oh, it was in the components, right? Okay. I'm not gonna do all the instructions because it's gonna be a bit tedious. Select the text I want you to select. Fuck you. Alright, let's just call it go without instruction, I guess. Why does it not display the thing? What is this? It's not external? What? That can't be right. That's not right. Oh, I typed it wrong. Of course I fucking did. Jesus. And right. That's pretty much all of it. There needs to be an invoke or an invalid instruction. Method. And in this case, we just do nothing. No. In this case, we actually want to emit something, which I forget how that worked. Parser, I think that was here. This is stuff. here's the label instruction, which has no parser, which is weird. Right. So we do much the same as before. Yeah. Actually, no, we don't need to do anything since the instructions are still represented in the AST. I actually just don't do anything at all with this. I think the instructions
still doing a good job.
Let's see.
Thought you should know.
Thanks, I guess. Yeah. Yeah, so it's still in the SD, so we don't actually need to do anything on the evaluation. Is there a standard method? Nope. Okay, good. So that's how you would define additional instructions. We're kind of abusing instructions here because we're not doing anything. Instructions are typically intended to change something about the parser state, but we're mostly just using them for things that we're doing once we actually run, execute, and apostrophes are text, so we're just gonna ignore that here. I'm gonna deal with the rest of the instructions later, because it has been 2 hours now, and I don't want to keep people up too late. So let me just take this here and slam it into a new file. We call this dialogue syntax.lisp. We're going to keep this including all of the things. We're actually probably use the markless components in this package. It's fine. Okay. And export the other stuff here. Jump. Need one of that. And now actually let's quickly define our own parser, which is going to be a markless parser. Just does that. Okay. And that'll be the syntax. So yeah, tomorrow we're gonna start, or maybe I'll start on my own and walk you through it, I don't know yet, but tomorrow is gonna be about the, or a compiler for this AST to something that can actually be executed. So yeah. Analog syntax extensions to markless. Okay. Push, please. Any day now. There we go. Good. And that's everything. I hope to see you tomorrow. That should be a fun stream. Alright, good night everybody. Bye-bye. Shut up, will ya?